Okay, so this video is talking about solving for missing pieces in a right triangle, whether that be a missing angle or a missing side length, using sine, cosine, and tangent. So as a reminder, in order to do this, we need to know what our ratios are. So sine is opposite over hypotenuse. So if we use our mnemonic of SOHCAHTOA, we have so. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and TOA, tangent, is opposite over adjacent. So this is just kind of to remind us of the sine, cosine, and tangent, and what each ratio has in it. So I'm going to go ahead and I'm going to let you know which angle we're solving for. So on number one, we want to solve for this angle, side length. So if we look at this, I have this angle right here is 30 degrees. And I'm trying to solve for the opposite angle, and I know the hypotenuse. I have no idea what this side is, so I'm not going to worry about that. So I need to use the appropriate trig function that deals with opposite and hypotenuse. Well, that would be O and H, so the only one that has that is sine. So I'm going to use sine, and the sine of 30 is equal to the opposite, which is x, over the hypotenuse, which is 6. So now I can solve this for x. So I'm going to multiply by 6 on both sides. And then these 6's cancel, and x equals 6 times the sine of 30. So sines, cosines, and tangents can be calculated in a calculator. So if I pull my calculator out and do 6 times the sine of 30, I'm left with 3. So this x equals 3. So I've solved that side. That side is 3 centimeters. On number 2, we're going to solve for this side. So now if I look at my angle right here, I want to find the adjacent side, and I know the hypotenuse. So this time I'm dealing with adjacent and hypotenuse, which is in cosine. So the cosine of 20 equals the adjacent, which is x, over the hypotenuse, which is 9. And again, I can now solve this for x if I multiply by 9 on both sides. So 9 times the cosine of 20 equals x. Excuse me. So if I enter that in my calculator, I have 9 times the cosine of 20 is equal to about 8.5. So this sine that I'm looking for is 8.5 centimeters. So 3 and 4, I'm now looking at a different angle. So on number 3, I'm going to try and find what my hypotenuse equals. I don't know what my hypotenuse is. So if I look at this angle, I know what the adjacent is, and I don't know what the hypotenuse is. That's what I'm trying to find. So I have adjacent and hypotenuse, which is what we just did here on number 2, was adjacent and hypotenuse with cosine. So the cosine of 25 equals adjacent, which is 12, over the hypotenuse, which is x. But if you notice, the difference between number 3 that we didn't have on numbers 1 and 2 is my x is in the denominator. So it's a little bit more tricky than just multiplying by that. So I'm still going to multiply by the denominator, which means that I'm multiplying by x. So my x's over here cancel, and I have x times the cosine of 25 equals 12. However, I'm not done at that step. My x is still not by itself. I've got to get rid of this cosine of 25. Well, since these are being multiplied, the opposite of that, I can divide by the cosine of 25. So I'm going to divide both sides by the cosine of 25, and then these cancel, and x equals 12 divided by the cosine of 25, which I can still do in a calculator. But I want you to be careful if your variable's in the bottom. You have a 2-step process instead of just 1. So on this one, I'm going to do 12 divided by the cosine of 25, and I'm left with 13.2. So this hypotenuse is 13.2 centimeters. On number 4, I want to go ahead and solve for this angle. So this is my side length. It's opposite my angle. So I know the adjacent, I want to know the opposite. So opposite and adjacent come from the last one we haven't done yet, and that's tangent. So the tangent of x is equal to the opposite, which is, oh, I'm so sorry, it's not the tangent of x, the tangent of 40 my angle. So the tangent of 40 is equal to opposite, which is x, over adjacent, which is 10. So this one is just like numbers 1 and 2. I can multiply by 10 on both sides. My 10's cancel. And I have 10 times the tangent of 40. So if I enter that in my calculator, I get about 8.4. So x equals 8.4 centimeters. So that's the basic process of finding missing side lengths. The next section we're going to talk about missing angles. So I'm going to go ahead and scroll, and we're going to look for angles that are missing. So if I look at number 1, I'm going to go ahead and write my SOHCAHTOA up here to remind me. So if I look right here, I'm trying to find this angle, and I know the opposite and the adjacent to that angle, which is what we just did. The opposite over adjacent is tangent. So to find this, I have the tangent of x equals opposite, which is 4, over adjacent, which is 8. So the tangent of x is equal to 4 over 8. So if I go ahead and think about this for a second, I want to get x by itself, meaning I have to get rid of my tangent. Well, that's not as simple as like plus 3, you just minus the 3. Subtraction is the inverse of the addition, so that's why when we have adding 3, we subtract 3. So the inverse of a trig function, I can literally take the inverse tangent to both sides, and then these cancel. So my x is equal to the inverse tangent of 4 over 8, which again can be done in your calculator. So wherever your tangent button is, generally the inverse tangent is right above the tangent button. So we would hit second, and then our tangent button, and we get inverse tangent of 4 over 8, which comes out to about 26.6. So my angle is about 26.6 degrees. Number 2 is very similar to number 1. I also know the opposite and adjacent, which again is that tangent. So I have the tangent of x equals the opposite, which is 2, over the adjacent, which is 1. And then I take the inverse tangent of both sides again, so I have the inverse tangent of 2 over 1, which gives me 63.4 degrees. Number 3, I now have a different pair of sides that I know. So if I look at my angle, I know the opposite and the hypotenuse. Well, up here, opposite and hypotenuse is sine. So the sine of x is equal to the opposite, which is 5, over the hypotenuse, which is 7. So then I can take the inverse sine of both sides once again, and these cancel, and x equals the inverse sine of 5 over 7, which comes out to be 45.6 degrees. And then number 4, I again know the opposite and hypotenuse, so I'm going to use the sine equals 3 over 6. So the inverse sine of 3 over 6 is 30 degrees. So this angle is 30 degrees. Now numbers 5, 6, 7, 8, 9, and 10 are actually probably the easiest ones on the page because already this is written for me. I don't even have to find that fraction. So to get y by itself here, I just take the inverse sine of both sides. So these cancel, and y equals the inverse sine, so inverse sine of 0.766, which rounds to about 50 degrees. So all you have to do is take the inverse sine or the inverse tangent or the inverse cosine of each sine, and you can solve for whatever this angle is. So I want you to go ahead and try that with me. So I will do it as you do it, and you can check your answers with mine. All right, so I now have all the answers up there, so go ahead and keep trying it. Maybe pause the video so you can check your answers with mine.